Hello everyone. So in this video we will study about the flyweight design pattern, and this is the last design pattern in terms of structural design patterns. Alright, so let's see what all is there. In this video we will learn the following things about the flyweight pattern, what is flyweight pattern, its UML class diagram, implementation using Typescript, and the interview questions. Alright. So let's see what is exactly the flyweight pattern. This pattern deals with efficient usage of memory or space resources by allocating some of the objects internally. So let me explain this. Let's say you are frequently using objects such as strings or cache values from numerous clients. Now it becomes enormously expensive to generate them on the fly every time. With this pattern, you provide an interface so the client can still benefit from using those objects but share them as much as possible behind the scenes. So in this way, when your objects are being shared, you don't really need to create new objects every time, thereby increasing the memory space. For example, sharing a few traditional costumes among many dancers. Alright, so see, let's say there is a group of dancers. Now 7 dancers are there, you have 7 costumes, you give them and they perform. Now again 7 new dancers came. Are you going to buy new costumes for them? It will be very costly. So you will reuse those costumes that were given to the previous dancers. This is how you do the sharing, and that is how the flyweight pattern works. Now moving on to see the UML class diagram for it. This is the UML class diagram, as you can see. So when we implement this pattern, we want to structure our shared flyweight object such a way that we have a separate shared state, means extrinsic state with a unique parameter to make specializations which are intrinsic. Alright, here you can see this is the client that uses the flyweight factory, and this is caching one or more flyweight objects. Okay, so you can see this is an interface and this array of flyweight objects you can see. Apart from that, there are two different flyweights. So these two different flyweights are being used to apply customization. Here you can see each flyweight object has a shared state that is common to all of them, and the customization part that makes them unique. This way they offload part of the responsibility to the clients, providing the unique parameter. So after that, we will provide a flyweight factory object that uses the shared state object and a unique parameter to create flyweight objects. That is how the UML class diagram for flyweight pattern works. Alright, so now we will move on to our IDE and see how this pattern works. Alright, here we are going to implement our flyweight pattern. So what I do is I create an interface flyweight. In this flyweight interface, increase some brightness for me. We will have, let's say, perform. We had a dancer's analogy, so yeah. Customization, and it can be any customization. Let's say ID. ID will be a string. Obviously, we want to make it unique every time, and this will return nothing. Now we will have concrete flyweight. It's a concrete implementation of that interface. Implements flyweight. Sorry. And I will press Control plus dot or Command plus dot. Here what we are going to do is we are simply going to log console.log and flyweight customization.id. Alright, this is the best log. What I will do is I will also have a shared state. This will be an object, simple. It can be any kind of object. So I am keeping this type as object, and I will have a constructor, and here also shared state object, and yeah, like this. I mean, you can do your operations here. So I'm really not doing anything because we are just showing that this is a shared state object which can also be used inside this concrete flyweight pattern, so that while sharing this state, which is an object, you know, instead of creating multiple objects, this one shared object will prevent the memory from overflowing. I will create a flyweight factory class flyweight factory. This won't implement the interface. Now there will be a cache. Cache equals to new map object flyweight, like this. Now we will implement a create method, public create, which will have shared state object, and this will return a flyweight. So why are we doing this? So we are here creating the cache. What I will do is I will check if this already exists in the cache, or maybe it does not exist in the cache. So if it does not have, then what we are going to do is this dot cache dot set shared state, not new flyweight, new concrete flyweight shared state. Otherwise, we will simply return the shared state from the cache. Alright. Now I'm going to use this. So before using this, let me tell you what I did. I created a flyweight interface which has a method. Here we have implemented perform method since we took the dancing analogy, and here is the customization in which you can insert the ID. So class concrete flyweight is now implemented using that interface which contains a shared state object, and you can do anything with the shared state object. We are just here to see the raw implementation of this pattern, and it has a perform method which just logs the ID. And here you can see the flyweight factory. This flyweight factory contains the cache, the map of the cache, so that the memory leak does not happen here. I mean, if you already have thing in cache, then you return that, otherwise you set that inside of the cache. That is how this pattern efficiently manages the prevention of excess memory uses. Now we will use this const line equals to new flyweight factory dot create state initial. Where is the state property? See, this is a shared state is an object. You can pass any property like this. Okay, I'm passing the state for better understanding. And now time to perform. And the ID will be my flyweight ID. Any ID you can pass, that's up to you. And here you can see this error is coming, so cannot redeclare block scope variable. Anyway, this is represented in another file. Instead of adding this file to tsconfig, I will rather do this my. Alright, this is fair enough. That's how we do. So now I will be running this code. So we clear the console again, and I will run this. as you can see, flyweight is flyweight ID. So our pattern is quite working, and that is how you can implement a flyweight pattern in Typescript. Now coming back to our slides, and here we have the interview questions. We will now focus on the interview questions. What I am going to show you is what are intrinsic and extrinsic states in the context of this pattern. So intrinsic state means this is the state that is shared among all the instances of a flyweight, the shared object that we saw. It is stored within the flyweight object and remains constant. For example, the font of a character in a text editor, like that. And the extrinsic state, this state is unique to each instance of a flyweight. So every time you instantiate the flyweight, it is stored externally and varies based on the context. Let's say the position of a character in a text document, it can always vary. These are the intrinsic and extrinsic state in the context of this pattern. Second thing, what are some real world examples of this pattern? So real world examples, let's say there is a text editor where characters are flyweights. So each character object contains a reference to its font, size, and other formatting details. And those formatting details will be called as an intrinsic state, and while its position in the document will be called as an extrinsic state and is stored externally. So here, by reusing character objects for different occurrences of the same character, memory usage is minimized. Third one, what are the benefits of using this pattern? So benefits, see, this contributes to the system performance first of all. Okay, the flyweight pattern improves the performance primarily by reducing memory consumption by sharing common parts of the state among multiple objects. And second is that this is easy to implement. Also, one more thing is that this also handles the thread safety. Flyweight objects should be immutable to be thread safe, meaning that intrinsic state does not change once they are created. These are the benefits. Now, drawbacks. So if I talk about the drawbacks, one major drawback is that increased complexity. Managing shared and unique states separately can make the system more complicated. Obviously, you have to clearly decide between what will be shared and what will be, unique. And some extrinsic state needs to be provided explicitly for each flyweight method call as well. These are the drawbacks. Alright, so here we end this video. This was the last structural design pattern in Typescript, and we studied about its uses, interview questions, criticisms, implementation, all. And in the next video, we shall study about what are the behavioral design patterns. Thanks for watching this video. Bye.